Hi, my name is Manteza. I am from CSE AML A section. My topic name is about peak-to-peak value from sinusoidal waveform. In this picture, we can see about the high, positive peak and negative peak in the graph. Now, we will see some introduction about the peak and value. The peak value of sine wave means the maximum value found on a sinusoidal waveform compared to the zero level. Other commonly used amplitude values are root mean square and peak to peak. Peak of sine is 1.414 times larger than the root mean square, that is RMS of a sine wave. Peak of sine is 1 by 2 of its peak to peak value. In this below graph we can see the peak to peak value and root mean square value. Here the root mean square value is lower than peak to peak. That means peak to peak value is 1.414 times larger than RMS value. Now we'll see some introduction about sinusoidal equation. The equation of a basic sine function is f of x equal to sin x. In case of b, the frequency is equal to sine 1, which means one cycle occurs in 2 pi. If b equal to 12, the period is 2 pi by 12, which means the period is 4 pi and the graph is stretched. And the second one is frequency is a different way of measuring horizontal stretch. For sound, the frequency is known as pitch. With sinusoidal functions, frequency is the number of cycles that occur in 2 pi. A shorter period means more cycles can fit in 2 pi, and thus a higher frequency is there in 2 pi, and the period and frequency are inversely related by the equation period equal to 2 pi by f, that is 2 pi by frequency. The transformation rules about horizontal stretching and shrinking directly apply to sine and cosine graphs. If the sine graph is horizontally stretched by a factor of 1 by 2, that is the same as the horizontal compression by a factor of 2. Now we will see some example about the sinusoidal equation. Earlier you are asked how an equation changes when a sine or cosine graph is stretched by the factor of 3. If a sine graph is horizontally stretched by a factor of 3, then the general equation is b equal to 30. This is because b is the frequency and counts the number of the fraction or the period that fits in a normal period of 2 pi. Graphically, the sine wave will make a complete cycle in 6 pi. Similarly, a cosine graph will have b equal to 13 and will have a period of 6 pi. The term sinusoidal equation is used to describe a curve referred to as a sine wave or a sinusoidal that exhibits smooth periodic os- oscillation. It is named based on a function y equal to sine of x. Sinusoids occur often in math, physics, and engineering signal processing. and many other areas. Now, this is a graph of y equal to sine of x. In the sinusoidal graph, we can see the peak voltage value and RMS voltage. This graph is taken by voltage versus time graph. Below are the sum properties of the sine function. Here the domain is minus infinity to infinity, and the range is minus 1 to 1, and the period is 2 pi. The pattern of the graph repeats in intervals of 2 pi. Amplitude is 1. The sine graph is centered at the x-axis. The amplitude is the distance between the line around which the sine function is centered, referred to here as a midline, and one of its maxima or minimum. Zeros is pi n. The sine graph has zeros at every integer multiple of pi. Sine minus x equal to minus sine x. The graph of sine is odd. The meaning is that the symmetric about the origin. The ability to measure the period of a function is in multiple ways allow different equations to model the graph. The, it represents a regular sine wave which with the horizontal shift and negative cosine wave which is horizontal shift. Its flexibility in perspective means that many of the examples guided practice and problems on this sinusoidal wave equation. Now we will see some information about peak-to-peak value. For an AC sine wave with no DC component, the peak-to-peak amplitude is equal to approximately 2.828 times the root mean square amplitude. Peak-to-peak value can be expressed by voltage, the usual case, and current or power. In the given graph, we can see the peak-to-peak value and RMS value, and here the blue line is a peak of sine and the red line is peak to peak value and the green line is root mean square value. Here root mean square is much lower than peak to peak value. That means peak to peak value is 2.14 times greater than root mean square value. Here in this graph you can see the graph is about peak to peak value versus periodic time, and the frequency is 1 by periodic time. Here we can see the sinusoidal wave on the graph. On this graph we can see the peak to peak value and RMS value, which is Vrms equal to V peak to 0.707, and average value is equal to peak value into 0.637, and the origin is 0, and the peak value is the maximum value. The peak to peak value is the voltage waveform which is measured from the top of the waveform called the crest all the way down to the bottom of the waveform called trough. You can see that all this shown in the above diagram. So peak to peak voltage is just the full vertical length of the voltage waveform from very top to the very bottom. In this graph, we can see the peak-to-peak value and the amplitude of the sinusoidal wave. Here the graph is between peak-to-peak value versus time variant. Here is some example about peak-to-peak value. You will encounter peak-to-peak value voltage in many environments. However, never assume a voltage is peak-to-peak unless directly specified as that. For the example, the voltage should say at the end peak-to-peak value. For example, 60 peak-to-peak is for the real-life example of the peak-to-peak value for an item. We can see the regularly in buildings wherever, including our home as an AC outlet. As we may know, AC outlets outputs are 120 volts. The voltage is not the peak-to-peak value. This is the RMS voltage. If we need some explanation about RMS voltage, we'll see some RMS voltage explained. The same 120 Vrms is 170 volts in peak value. So in peak to peak value it is 340 volts. So the voltage which comes out from the AC outlet is 340 volts peak to peak. Now we will see how to calculate the peak to peak voltage. Peak to peak voltage can be calculated either from the peak voltage or RMS voltage or average voltage. The formulas are to calculate the peak to peak value for either these three are given below. Peak to peak value equal to the peak value into 2. If you are given to peak voltage value, we can calculate the peak to peak voltage using the above formula. All you need to do is obtain the peak to peak value, multiply the peak voltage by 2, and the next one is peak to peak voltage equal to Vrms into 2.82. If you are given the peak voltage, you can calculate the peak to peak value using the formula. All you have to do is the obtain peak to peak value by multiplying the peak voltage into 2.82, and the next one is the peak to peak voltage equal to V average into 3.14. If you are given the average value, you can calculate the peak to peak value by this above formula. All you must do is the RMS value is to multiply with average value into 3.14. This is the information about the peak to peak value of sinusoidal equation. Thank you.